Good morning. Uh, Welcome to my first ever presentation at any conference whatsoever. Docker for Perl, actually for Yaldi Perl. Um, my name is Wesley Schwengle. You can find me on IRC. It doesn't work. You cannot hear me. Oh, okay. Um, uh, can you hear me? Yes. Oh, okay. Well, I wrote my name down because I was so nervous. Okay, let me start over. Welcome at my presentation, Docker for Perl. My name is Wesley Schwengle. You can find me in IRC as Slacker or CPAN, Waterkip. I work for a company called Gitlab, and we make a case management system called zaaksysteem, which is open source APL. What does it do? I always say it's a glorified request tracker for governmental use. We have 25 governments, 25 local municipalities using our software. So this presentation, it's mainly about Docker. It has a little bit of Perl. I think, who uses Docker here? More than I expected. A little bit of JavaScript, maybe, and something about Gitlab CI. So why do we use Docker at my company? Well, we had a problem. We did development in Vagrant, and that caused that every developer had his own development environment. And when we did deployments, we had 5 VMware servers that we were deploying to, and that was excluding our test platform. And we had major issues with JavaScript because the build was no. When you minify the JavaScript, the build changes. And every OS has its own quirks in Vagrant. Windows, especially with NPM, tends to have different file paths and so on. We weren't really ready for microservices, and the deployment took ages because of the NPM issues that we had. So we went looking for something, and we came to Docker and Docker Compose. We prototyped it with CoreOS on VMware. Basically, Docker, you can run a container, and Docker Compose lets you orchestrate all the containers within a single YAML file, so you can actually create your production environment on your laptop. And Docker Compose also is used by Docker Swarm. So, our migration to Docker, first of all, we updated all of our libraries. And we went using from System Perl, which was 5.14 or 5.16 on Ubuntu, to the latest version of Perl at that particular time. And every developer now has the same box. Actually, we all have the same environment as we run on our production servers. And we do that via Docker Compose. And we deploy via Gitlab CI and Kubernetes to our OpenStack cluster. And it scales a lot better because we can easily add a machine via Kubernetes, and then we just Kubernetes pulls the image, and we have a running machine. And so we can easily add microservices. So you have a Docker file, which is looks like this. And one container runs in single service. And in the Docker file, you just describe how you build that container and what that container does. And The downside is you cannot do really scripting inside a Docker file. So if you want to do something special based on an environment variable, you should do that in a shell script or, well, any kind of script. So yeah, layers. Layers are building blocks of Docker images. Every command that you saw over here, so this is a layer, the copy command is a layer, and the run command is a layer. And it leaves behind, it can leave behind build artifacts. And each layer actually is read-only, except for the last one. So when you run a container, that small layer is writable. So you can go in the container, edit a file, save it, and then that change is recorded. You can find all your layers in varlib docker, in AOFS or overlay too. You can change the path in your daemon.json file, which is in docker. And I did it some insane project for work, and I found out that the maximum amount of layers is close to 200. And that's in a single Docker file. I don't know exactly how it works if you have multiple things, but single Docker file. So, if you have a Docker file and you want to create your image, you run docker build. And if you want to see what images are installed on your machine, you can say docker image ls. If you want to view the history of an image, you can see docker image. You can actually see what the build commands were of that image. I can show you. Where's my mouse? Well, this is the image that's actually serving you the presentation. So over here you see every command that we had in the Docker file. And you can see how big it is as well, which is, you want your image to be as small as possible. So it fetches quickly and so forth. You can tag an image, or you can actually tag a layer. So every individual layer, you can make it an end product by tagging it, and then you can use it later on as a building block of another image or the end product. Or you can do it with docker build -t, and then you tag it directly. Containers. Images are not containers. A container is actually your running image. You can think of it as classes and instances. So a class, that's your image, and the running thing, the instance, is a container. So we have a few Docker commands. You have some that are similar to Git: pull, push, tag, commit. You have some others: build, inspect. If you do docker inspect, you can get information about the internals of the particular container or image. And you can, with Docker container, you can list all the containers that are visible on your system, and Docker image all the images, and well, there are more volumes, etc. And some can only be used when you're using Docker Swarm. Docker Compose. This, I don't know if you know this series, it's a fun one. So, at work, we have a Docker Compose.yaml, and we have two Docker files that basically represent our project. we have a backend file which just contains all the Perl stuff, and we have a front-end file that contains all the JavaScript stuff. And within our Docker Compose YAML, we say that the backend service uses this particular Docker file and it's dependent on the database image. And for the front end, we have this particular Docker file, and we say it depends on the backend. So as soon as you start the front end container, you will start the backend, which will in turn start the database. So you can have your dependencies. Like if you set this correctly, you start one container and everything starts up for you. You can also run them without dependencies with a special flag. And well, as you can see here, this is from within the project. But you can also use external images. For example, we use Postgres 9.6. We use that particular image. It's fetched from Docker Hub, and we expose these ports so we can connect to it. And if you're a developer like us, you sometimes want to override the defaults. You want to include, for example, we have some proprietary things that we want to use, and then we use that particular project. So we link to it with, in this case, it's one directory below my main repository, some project, and I can use that particular Docker file to build it. Or let's say I push something and I want to use it from my own registry, I can use it. Or test a new Postgres version, and you just change it in the Docker Compose override. So I'm editing files and I want to run my test suite. When you have Docker Compose and you don't have volumes, you need to recreate your container every time. You don't want that. So you can use volumes. And basically this is what we have. So my libraries and my bin directory is shared with the container. So I don't need to restart my container every time. I can just go into the container and run my test. Well, I should also export T, but or persistent data. For example, you don't want to have your database to lose all the data after a stop of the container or when you rebuild it or whatever. So you can say somewhere in your Docker file you say that you have a volume called database data, and you can then use it and mount it as valid Postgres data, and well, you keep that data. If you shut it down, it stays there. If you boot it up, it comes back up. We use this a lot for RabbitMQ database files, and we have some file store as well. It's really handy. If you change something in your Docker Compose file or your override file, you need to recreate that container. You don't need to rebuild it, but the image, but you need to recreate your container. You can do this with these two commands. When we first started out with Docker, we didn't know, and we had to rebuild containers every time, which was time consuming. This is the quicker option. It takes like 2 seconds. Okay, so at work we have a maintenance script that rebuilds all the containers for us. So every sprint, well, we really use sprint, but every 2 weeks, it's basically up to the developer discretion. We recreate all the images and all the containers on our local box. And just to make it easier, also for people who are not really technical. For example, our UX guy, he doesn't have any clue how things work. He just knows how to run that script, and we update everything for them. And for time-consuming layers, which is for us our Perl layer, which has a lot of dependencies, and rebuilding that takes an hour. So we don't want to force developers to spend 1 hour waiting. So one developer has to change it, pushes it to the registry, and then that artifact gets used by our backend container. And we have a script that deals with that and does the version management of that layer. And we're not really set on how we do version management. We now use basically a combination of the SHA-sums of the backend base layer file and our CPAN file to say, okay, this is the version, but we're not really sure if that is the best way. But anyway, we have a way. Are you still with me? Do I make sense? Yes? So, building images. This is a Docker file. This is a really, really basic Docker file. It has Perl latest, which is currently 528. We copy whatever is in our repository over to the Docker context, and then we run cPanel. So basically, this installs my CPAN module in my container. But this is very, very inefficient. What it does is, if you install something with cPanel, it fetches the sources from cPanel, puts it somewhere in a directory, runs the tests, and it keeps it there. And this will actually increase your image size tremendously. What also happens is, if you make a change in one file, it will reinstall all your dependencies again, because it has nothing to cache from. Well, I got a little bit ahead of myself. So you don't make use of the cache, because Docker can actually, if it sees that something has changed, it will, every command that follows it will be executed, but if it didn't change, then it will just grab it from the cache. So what you would like to do is you copy your cPan file or your makefile.pl, and you want to copy that first. If nothing changed, then the install deps command will be taken from the cache. You won't take it from cPan. So it will use the old build artifact, and then you copy over everything, and then you can run it. So actually, when you make a small change, only these two gets executed. I prepared a little example. So I have two Docker files. One is just the inefficient one, and the layer file. So, oh fuck. Well, now I'm doing everything. This will take a while. I think I threw away all my images yesterday, so let me give Docker ignore some attention. Have a Docker ignore file in your repository. If you have very big files in your repository, let's say a log file, or sometimes I have a customer database locally on my machine, and your build will take ages and ages and ages. Or if you have some kind of, if, for example, you run npm install, it also leaves node modules directories in your repository. Put those files in your Docker ignore, because it then won't send them to the contacts, and your build will be a lot quicker. If you look on GitHub at Moby's repository, there's an issue open for this. My build takes ages. Oh, big files. You want to have a Docker ignore. You can exclude files from a copy command. Its syntax is similar to a git ignore. The only downside is if you have, for example, we have two Docker files. You cannot say use this Docker ignore or use that Docker ignore, so you have one for your whole project, which is a little bit shameful. Or, let's see if this, still running. Then, another way to build images, and it is pretty newish multi-stage build. They're pretty cool. I haven't done much with it in regards to Perl, but I was working on, I don't know if you know LastPass. I was working on that CLI client, and I gave them a Docker file, and I got the request from one of the maintainers to make it in a multi-stage build. Didn't really saw the need for a multi-stage build on a LastPass client, but I thought, hey, I have a project that I work daily on. Let's work with it. So I made our JavaScript build a lot quicker. It went from 5 minutes to 2 minutes on our GitLab registry. But the most important thing is I went from almost 1 gig to a little shy of 200 meg. So that image gets pulled a lot faster right now, and it's smaller. It consumes less space. And that's done via multi-stage build. And if you use one of these versions of Docker, you either have multi-stage build or you don't. There's one small issue that I found out when I was doing some work on the Docker pull image. The official Docker images, the build process for the official Docker images don't support multi-stage yet. Well, what is multi-stage build? This is the Docker file for Perl 5.23. And this leaves a build artifact of around 800 meg. And that's mainly because it uses build backed up dependencies, so it has every build tool that Debian has, well, almost everything installed for easy installation for other things like this. And if you do a multi-stage build, you can define stages. So now you say, okay, this is my base image, and I say that it's the build phase. This is the same as what you saw. And then I define another image, another base image, which is stretch slim, which is a really small image from Debian, as runtime. And then you can say, I want to copy over the build artifacts that are in Azure local, and I copy it towards my current image. So you only get to have the things that you want. And there are two notations. You can use copy from 0, basically, which is this thing, or you use the name that you defined it, and then you can use that particular thing. I would advise you to use the lower one, because if you, for example, move this one down and put something above, you would need to change that from 0 everywhere. Pain in the ass. Those separate stages, you can use it as a target for your Docker. So you can say, for example, I only want to have the build phase. I want to have that as an image. So you can say -- target on that particular thing. And you can also do it with Docker Compose. You add a target. If you want to override it in Docker Compose, so for example, that you have some kind of development target, you can say this is my target now. That's what we do with our front-end developers do that. They get, like, we have an extra stage that installs all their development dependencies. So they override it in their override file, and then they can do whatever front-end thing that they want to do in their container. as I said, I haven't done anything with, well, not much with multistage Perl. What I don't want to have in my container is all the test dependencies. I don't want to fetch all the sources when I do multiple installations. So you want to copy over particular bits from your build phase. Let's see if that other thing is done. No. Okay. Well. So this is the Docker Hub for Perl. This is the main repo on Docker Hub. You can use these images for your own image. The other tags are well, basically the versions, but they use the latest patch level of Perl. So if you get latest, if 528.0 gets a new patch version, so let's say .1, then if you pull latest, you will get .1. 5 is also always the latest. Well, basically this is the scheme. The image size is roughly 800 max, and it's really good for building your image. But it's, in my opinion, too big for actually a running or the final layer. So I submitted a pull request. They shut it down, but because of that, it got the ball rolling again, and they made a slim image, which is now 112 max big. So and it's really nice because you now are the image of our own project was over 1 gig, and now it's if I use this, it's like 200 meg or something. So yeah. There are some annoyances with Docker and Perl. One is pretty generic. That's nothing to do with Perl actually. You cannot use volumes in a build phase. So you cannot have one machine that, for example, installs, let's say your build machine. You cannot keep your build artifacts in a volume so it can reuse them later on, which is kind of annoying. cPanel, it doesn't bail out when something goes wrong. So if you have a huge dependency, if you have a huge CPAN file with a lot of dependencies, it installs everything where one module didn't install, and it's really a pain in the ass to figure out which module it is because you lose most of the information. And one of my biggest gripes is it doesn't install modules in the same order. So it's a little bit, every build with cPanel is different, which kind of defeats the purpose of Docker in a way. And you get something like this. Hold on. Sorry. Well, this is the Docker file of my company. And then you get like this particular thing because you want to make sure that all the dependencies are set up correctly. So because cPanel changes everything every install. Yeah, you need to fix this somewhere else in your Docker file, which is a little bit, yeah. Are there any questions about this? Okay. Gitlab CI. What we do is when a developer commits something and pushes it towards our development environment, actually to one of the branches, it runs a pipeline, and then Kubernetes picks it up. Well, actually, GitLab CI sends a signal to Kubernetes. Kubernetes picks it up and then deploys it on our platform. And we then also push images to GitLab registry and Docker Hub, so well, Kubernetes can fetch the images actually. And this is really nice. And this is a GitLab CI YAML file, a really basic example. It's actually similar to the Docker file that I showed, the first Docker file. This doesn't cache anything. So every push gets, it basically builds everything from scratch. You don't want that. So you can change it a little bit. You use Docker and Docker. So this is some boilerplate that you use. So you use some environment variables, and you define two stages. Well, in this case, there are two stages: a build phase and a test phase. And then you can say what should be done in a particular stage. So over here we built the image, and unfortunately GitLab doesn't support multi-line YAML. So, but I did this because it reads better. What I do over here is I try to pull the image which is similar to my branch name. And I try to pull the latest image. And latest in Docker is a convention. So you always get the latest build artifact, or that can be the latest stable one or the latest development. It doesn't really matter, but this is the thing. And for us, latest is always what is in master. And over here, I can say this build will run for every branch except the master branch. So I pull those images, and then I can say to my build, use the cache of these two images, and then tag it and push it to the registry. Now, if I do a small cone change, it will use the artifacts of those previous images, and so my build, instead of taking 5 minutes, takes a minute or so. And this is the pattern. And then my test phase just fetches the image and runs the proof command. And if your test fails, your build fails, and then nothing gets pushed towards to the platform, for example. And then this is what I do for when we are in master. I also use Docker for my CPAN modules. My workflow is basically I have this Scylla thing that I started. My plugin bundle, or my minting bundle actually, takes care of all the boilerplate. And as soon as I push my initial, when I say diesel new module, when I push, I have a working GitLab CI, and I do manual releases to CPAN. And just before this talk, what I do on GitLab is basically I can only merge stuff once my pipeline succeeds. Therefore, I use the GitLab CI file that I showed you. I snip, and this is my Docker file. It's really simple. It's not intended to be small. It just needs to install and run so I can see if everything works. GitLab CI and Travis, there's a little bit of difference. Travis lets you test against multiple Perls. Docker CI, GitLab CI doesn't, unless you do, well, you actually do the work and create a Docker file for that particular version of Perl. And my workflow is I only add a Docker file if CPAN testers report a failure on a particular version of Perl, and then I add it, and then I add it in the GitLab CI, which is, it happens almost never. And I realize it may not be workable for like CPAN modules that are high up the river. For example, Perl that needs to test against a lot of versions of Perl. This approach won't work. Although, I think that if people start using Docker more, you would have less of an issue with older version of Perl, because you can just say, I want the latest version with all the patch sets and whatever. So yeah. Well, I went a lot quicker to my presentation than I thought. A summary. Docker, each command is a layer. You want to hit that cache more often than not. Things that change really frequently should go at the bottom of your Docker file, so everything gets is used from the cache. You want to have a Docker ignore, and you want to make your images as small as possible. Getting a small base layer like DB and Stretch Slim works, and multistage builds also work really nicely because you can actually pick what you want. Docker Compose. It's really nice if you want to have recreate your production platform on development box, and you can allow local overrides, so you can play with it. You can test different versions of databases and whatnot, and it's used by Docker Swarm. So, questions?
Just say Docker Swarm.
Docker Swarm is a orchestration tool. It's similar to Kubernetes. With Kubernetes, you can you have a YAML file that similar to what you saw in a Docker Compose, where you define what service and what runs where, and that's basically by Docker. And Kubernetes is from Google, so it's like orchestration tools for your platform.
That shell command back on the other window, how's it doing?
Ah. It's finished. Well, this is something you don't want to have when you're developing. Thank you, by the way. So I hope this one is a little bit quicker. Yeah. Okay. So this was what was supposed to happen in the last one. So as you can see, everything is used from the cache, and so now I changed something, and if I run the layer file, which makes use of the cache, you will see that it will not install all the dependencies, and it will only, as you can see, using cache, and over here it doesn't use the cache, it just copies everything over and then it installs. So it's a lot quicker, because if I would now use the non-cache version, this happens again. And I also have a multistage Docker file, which basically say, okay, I only want to test my I don't really need to do this now. It's a multi-stage, so I can just say, well, no, that's not true. I want to test the installation dependencies, then install them without test, and then I want to copy over everything that's in user local. I can run my tests, and then I can create a runtime thing. And hold on. over here, I don't know, you can probably not see it, but I have these two. This, the TPIG is and the layer ones are not the multi-stage, and they're around 900 max big, and the multi-stage is only 170 max, so there's a huge difference if you use multi-stage. I want to say multi-stage is not always the best solution. Sometimes you just need to clean up after yourself, do your own housekeeping. But it definitely helps in making things smaller. And another, no, I think I'll leave it with this. I went a lot quicker in my test. I bumped to the 55-minute mark, and I'm done in 40. So.
Do you have any experience using Docker together with cart or installers?
Sorry, Docker with?
Cart.
Docker. If I have experience Docker with Garden, no, I don't. I think I was at the presentation for the pull request challenge, and there was a guy that runs Docker with Perl brew. Maybe, I think he's sitting over there. Maybe he has some ideas of how to use that. In my opinion, if you use Docker, you don't have to use Garden or Perl brew, although he had a prime example of when Perl brew in a Docker container is really nice to have. So you can have just one Docker container that runs every kind of Perl. So, but in general, you want to have one Perl version in your Docker file.
Cart is more for replacement for cPanel.
No.
Basically the same as
Basically the same.
install apps.
Right, so it's okay. Thank you.
No.
Docker decided to clear out the obsolete junk.
Good question. I don't have an answer to that, unfortunately. The question was, how does Docker know when an image is obsolete? I don't know. There's a nice. Hmm?
It doesn't run out of disk space.
Yeah, that's an issue. I make sure I made the mistake once of not remembering that I wanted to use Docker, and I had a small root directory, and then suddenly my disk was full. Luckily, you have commands like well, they're fairly new, but you can run Docker system prune, and it will remove everything for you. And I have some shell scripts that will basically almost wipe everything from my system, so I can start over if I need to. But I don't advise it, especially the day before you have a presentation.
Don't you can, your presentation is over.
Yeah.
Do you ever bash into a container?
When developing, yes. When we do system maintenance for well, our customers, no.
Question?
What was the question?
Oh, sorry. The question was if I ever enter a container. But it's really easy.
Yes.
Well, you get a regular shell.
At the top, maybe.
You show the command at the top of the screen, but you don't see.
Sure.
I can see the command in the back.
Ah.
Scroll it up.
Ooh.
Scroll it up.
Hold on. So basically, you say Docker run with the terminal interactive, the image name, and then the command that you want to run. You can also, for example, if you just want to run your test suite, sorry, you can do this, and it will run that particular command for you, and then exit. Now you have a working container, and well, you see that everything is copied from my repository, and the cPanel artifacts are also there. Let's say I want to. Oh, this is also a really nice thing. My container doesn't or my image, it doesn't originally have a file called foo. Let's do something else. So I echoed foo into foo. Anybody see my mouse? Well, I'll leave it at this. I want to show you that you can actually you can add a file, and then you can use Docker commit to change that foo change. You can basically change something, commit the change, and then you have a new layer that you can reuse to build it. So if you have intermediate images, you can basically say, okay, I want to have this layer, and I want to change this, and then I want to use that and tag it, and then you can use that layer later on in your build process for other things. So that's it. I'm gonna make a PDF out of this, and then I'm gonna push changes towards these two locations, and then you can grab the files and the examples from the repository, and then you can play a little bit with Docker if you want. And I hope it was useful. Thanks.